right, now we're going to transition into Chapter 9, and Chapter 9 is just a series of tables, okay? So we're going to pick up where we left off here in Chapter 9, and we're going to start off with the start of Chapter 9, which is Table 1. And so this is on page 715, Chapter 9, Table 1. Table 1 is a percent of cross-section of conduit and tubing for conductors and cables. So this is just the general percentage that we build other tables with. So for a single conductor, we're going to have a 53% fill. For two conductors, a 31% fill. And if I get over two conductors, that's going to be a 40% fill. And so that's the general fill area that we're going to need to have on any of these conduit or tubes. And so for a single conductor, 53%. Two conductors is 31%, and then over two is 40%. So the next table we're going to take a look at here is going to be Table 4. And so that starts off on page 716. Table 4 starts off on page 716. And Chapter 9, Table 4, again, is a series of subtables. All right? And so when we're taking a look at that, we need to understand that these tables start with EMT and then go to ENT and FMC and IMC, and then you got IMC's continued, and then you got LFNCA and LFNCB and LFNCC. And so I like to highlight the headings on those so I don't get on the wrong table, because each one of those types of conduit or tube has different characteristics. Exactly how much you can fill on them, things like that. That's why there's an individual table for each of those. So Schedule 80 PVC here, then we got Schedule 40 PVC, we got Type A rigid PVC, Type EB rigid PVC. And so it goes on basically through page 720. That EB rigid PVC, that continues on to page 720. And then we have Table 5. So Table 5 starts off on page 720 and goes through 723. This is our dimensions of insulated conductors and fixture wires. And what we're going to do is we're going to hang out in the approximate area in square inches, okay? Not the square millimeters, not the diameter, but the approximate area in square inches. So that'll tell us how much physical space each individual conductor will occupy. Now, different types of insulation will have different physical characteristics. So RHH, RHW, RHW2, those are all the same size, but that's going to be different than a THHN. And so we have things grouped together as to the ones that are the same size and the ones that are different, okay? So again, we want to get our approximate area in square inches. And then Table 8, Table 8's our next table that we're going to take a look at. That's on page 725. Page 725 is Chapter 9, Table 8. And this is a table that we can use for our voltage drop calculations. So it'll tell us basically the resistance, which we could use for our voltage drop for using the Ohm's law method. And then also the third column over there, we looked at that once before, the circular mill area of the conductor. And you'll see it's 1620 and it goes down, and basically there's a dash when it hits 250. And the reason why there's a dash when it hits 250 is because the name of it tells you exactly how many circular mills there are, right? So a 250 kc mill, that K means 1,000, so that's 250,000 circular mills. You'll notice here on this 18 gauge conductor, the 16 gauge conductor, there's actually two different resistances. And this is our resistance for 1,000 feet. That's what the ohms/KFT means. That's ohms per 1,000 feet. There's two different resistances on there because one of them's solid and the other is stranded. So the top number is our solid conductors, and then our bottom number is the stranded conductors. Annex C, what it does is it combines together the information that we have in Table 4, which is the size of the conduit or tube, and Table 5, the size of the conductors, puts those together into one calculation. And basically, you could take a look at this and you could say, okay, if I've got RHHs and I've got 2-inch RHH or 2-inch ENT, right? How many 1/0s can I put in there? And it says you can put in 4, right? Now this table only works if all the conductors are the same size and they have the same insulation. If they don't have the same insulation or they're not the same size, we're not allowed to use this table. We have to manually size that using tables 4 and 5. So Raceway sizing. Sizing a Raceway comes down to knowing the size of the conductors and knowing the size of the Raceway that will accommodate them. So Chapter 9, Table 5 lists the approximate conductor area based off the worst case scenarios for round, concentric, lay-stranded conductors. The actual values can be used if known. So if I know the actual size of that, the actual area, we can go ahead and use that instead of the numbers that we have in Table 5. So those numbers have been calculated for us, and we're going to hang out in that approximate area in square inches. So for that 18 gauge RFH-2, that is going to be 0.0145 square inches of area that occupies, right? Whereas a number 10 RHH is going to be 0.0437. So our cross-sectional area is expressed in circular mils, or in this case, we're going to use our square inch area because that's going to include our insulation in there. So that's what we're going to do for our voltage drop calculation. Okay. So our number 8 THWN, if we looked at -2, if we look that up on the table, and let's go ahead and do that right now. Let's go to Chapter 9, Table 5. Chapter 9, Table 5. And we're going to look for a THWN2. THWN2, I can see that down at the bottom of page 721. And we're going to look at a number 8, right? And I go over to my approximate area in square inches, and that's 0.0366. Sure enough, that's consistent with the graphic there. So we're probably barking up the right tree. So that includes the insulation that's on there, right? Not just the size of the conductors. The circular mill area is basically the size of the conductors in the circular mills, right? All the stranding and everything bundled together, that's what that expresses. This is the physical size with the insulation on it. So here I got number 10, RHW2. RHW2, I see in page 721 as well, middle of the page there. We're going to go down to number 10. And it says 0.03, I'm sorry, am I looking at the wrong section here? Oh, there's an asterisk on there. We need to pay attention to what that asterisk says. That's without the outer covering, okay? In this circumstance, we're talking about with the outer covering. It doesn't say on the graphic, but, oh, it does. It says with an outer cover. So we want the one without the asterisk. That's on page 720. Okay, and it says 0.0437. In fact, that is the size that they have on there. So that brings up a very important point. When you see an asterisk, when you see some sort of symbol on there, you need to see what that's for. All right, in this circumstance, what I would do is I'd look for the asterisk, and then I would flip my pages until I see a note down at the bottom that says what that asterisk is for. And sure enough, on page 724, down at the bottom of the table, it says the RHH without the outer covering, all right? And so the graphic showed with the outer covering, and so that's why that's the wrong number, and the one that we came up with is the right number here. The one without the asterisk, that's with the outer covering, all right? So you could go on, you could check those, make sure you know how you're doing that. But that's basically our first step. We're going to size our conductors, okay? Now the raceways, the conductor fill on that's going to be based off of the number of conductors that we have in there. So for a single conductor, we have a 53% fill. For 2 conductors, a 31% fill. For 3 or more conductors, a 40% fill. And so that's going to be off of Chapter 9, Table 1. When all the conductors are the same size and the same insulation, that's when we can use Annex C. Kind of a shortcut that gets rid of the math. All right, let's work out a few examples. So here I've got 1/0, THHN. I've got number 1, and I've got number 6, okay? So I do not have all the same type of conductors. I don't even have the same size conductors. They're all the same type, right? They're all THHN, but they're not the same size. So what I have to do is I need to size this manually, all right? And so we've got 1/0 THHNs. I've got 3 of those. I can see that, right? And so what we're going to do on Table 5 is we're going to find our THHN, all right? And so THHN, I'm looking here on my table. I finally see it here on page 722. But it's also down at the bottom of page 721, and that's what we need, the 1/0 there, and it's 0.01855, right? And so we would use that. We'd do that times 3, and then we'd add a number 1, and that would be 0.1562, right? And then we would add a number 6, which is going to be 0.0507. And so we'd take those, we'd add those together, and we'd come up with a total, and then we'd take a look at our conduit or tube out of Table 4 to figure out exactly what size that we would need, all right? So in this circumstance, we're looking at Table 4. This one happens to be for EMT, so let's flip back to Table 4, see if we can find that. And we're going to look at those headings, see if we can find EMT. That's that first table there on page 716, right? And so this is just a reprint of that, kind of squished up so that it actually fits on the screen. But all the same information in there, so you can see how that all lays out. Now, if I've got over 2 wires in the conductors, in the conduit, we're going to use that 40% fill. If I've got 1 wire, we'll use the 53% fill column, and 2 wires is going to be 31%. Where we use the 60% is when we've got a nipple, an area of conduit that's only 24 inches or shorter. We don't have the physical limitations on that, so that's when we would use that 60% column. All right. What is our cross-sectional area permitted for conductor fill for a trade size 1 EMT that's 30 inches long and contains 4 conductors? So if it contains 4 conductors, that's over 2 wires, right? So we'll use the 40% column. So what we're going to do is we're going to find our EMT, and then we're going to go to our 40% column, and we're going to go down to 1 inch, and it says 0.346, right? And so that is what we do, and so that can be filled 0.346 square inches in cross-sectional area. What about our cross-sectional area of trade size 2 EMT? If I've got how many wires? 4 conductors. Okay, so we're going to use the over 2 wires. And so trade size 4 is what? I'm sorry, trade size 2 is 1.342, right? And sure enough, that's what comes up on the screen. What about minimum size EMT required for 3 conductors having an area of 1.25 square inches? Now they're asking that different. They're saying, hey, this is how much I have, right, as far as fill in there, 1.25 square inches. Find me an EMT that'll accommodate that. So what we're going to do is we're going to go into the over 2 wires category because it says 3 conductors. and we're going to find something that will accommodate 1.25. And so that is going to be what? A 2-inch? Yeah, so we're going to go down. 0.0184 is not going to cut it. 2.343 is too much, right? The smallest size that we can use for 1.25 is going to be that 2-inch, which will accommodate 1.342. What's our minimum trade size Schedule 80 PVC required for 3 conductors having a total area of 0.35 square inches? Now, first thing I pay attention to is, hey, we're not talking about an EMT anymore. We're talking about Schedule 80 PVC. So we're going to have to find that table. So hopefully you've noticed that detail and are already looking for our Schedule 80 PVC, which starts down at the bottom of page 718 and continues on top of page 719. And we're going to find something that can accommodate 0.35 square inches. And so again, I've got 3 conductors, so we're going to hang out in that 40% column. And we're going to go down until we can find something. It looks like 1.25 is what we're going to need, right? And sure enough, 1.25 is the size that we're going to need. So that's basically how you do those, right? If that Raceway doesn't exceed 24 inches in length, now we can use that 60% column, okay? So if they say, hey, it's only 24 inches in length or it's 12 inches in length, we call that a nipple, right? Then we can use that 60% column in there. So let's do one using that, all right? What is the cross-sectional area permitted of conductor fill for a trade size 2 EMT nipple? So now we're going into the 60% column, and we're going to find EMT. We go down to trade size 2, and it says what? 2.013. That's all there is to that. The time when we use that 60% column is basically when we're dealing with a nipple. Okay. Now let's take a look at actually doing a calculation here. We use tables 4 and 5 in combination, right, to size this stuff. So here, our Chapter 9, Table 5 will give us the size of the conductors. Chapter 9, Table 4 will give us the size of the Raceway conduit or tube. Our raceways need to be large enough to pull those things through without damaging the insulation. And so step 1, what we're going to do is we're going to determine the cross-section area for each conductor. And then we're going to select the raceway that will accommodate those from Chapter 9, Table 4. And so here, I've got some 500s, and I've got I got a 250, and I've got a number 3. So what we're going to do is we're going to go to Chapter 9, Table 5, Chapter 9, Table 5, and we're going to find this THWN2, okay? So I'm turning some pages, find Chapter 9, Table 5, THW2, THW2. I find that on page 721, but let's see. I've got some asterisks in there, but not next to that THW2, so I'm okay. Oh, I'm sorry, it's THWN2. That's going to be important as well. So THWN2, page 721, bottom of the page, that's where I start to see that. And we're going to go down, we're going to find our 500 kc mill. That actually takes us to the top of the next page, right? And so we go to 500 kc mill, we go over to our square inch area, and we find that's 0.7073. That's for one conductor. We've got 3 of those, so we're going to have to take that times 3, and that gives us 1219. And then our 250 kc mill, that's actually at the bottom of page 721. We go over to the third column over there. It says 0.3970. I've got 1 of those, so I don't have to multiply it times anything. And then I've got a number 3 in there. So I go up to my number 3, and it says 0.0973. So now I've got my 2.1219, my 0.3970, and my 0.0973. I'm going to add all those together, come up with a total volume here of 2.6162. And then what we will end up doing is we'll take that to our Schedule 40 PVC. Why? Because the picture shows Schedule 40 PVC. And we're going to go back and find that in Table 4 and find Schedule 40 PVC. And so my Schedule 40 PVC, that's going to be the middle of page 719. And then which column are we going to use? We're going to use the 40% column, right? Because I have over 2 wires, right? And so we're going to go down until we find something that will accommodate 2.6162. And that's going to be a 3-inch, right? That'll give me 2.907. And so we're going to use a 3-inch Schedule 40 PVC to accommodate 500 kc mil THWNs, 3 of them, 1 250 and 1 number 3. So this is another one. I've got EMT, right? So we would use a different one. If we looked up the values for the THHNs, a 3/0 THHN is 0.2679. That would be from Table 5. We have 3 of those. So we're going to do that times 3. That gives me 0.8037. And then my number 1 THHN, that's 0.1562, just one of them. And then my number 6, I've got 0.0507. And just one of those. So if I add that total area together, I get 1.0106. And now it asks me about EMT, so I got to find the EMT table in Chapter 9, Table 4. And we're going to go over 2 wires, right? Unless it's 24 inches or smaller. It doesn't say that it's 24 inches or smaller, so we're going to use the 40% column. And we're going to find something that can handle just over 1, so that's going to be a 2-inch. And so that's how you do those manually using tables 4 and 5. Okay? Annex C can be used where all of our conductors are the same size and the same insulation. So when all of our conductors in a raceway are the same size, the number of conductors permitted in a raceway can be determined by simply looking at the tables located in Annex C. So if you're not there already, turn to Annex C. Annex C starts off on page 773 with kind of a table of contents. And if you look at the table of contents, it starts at page 730, goes all the way to 814. That means that that thing is about 80 pages long, 85 pages long, right? So you got to get on the right page, and that's the number one thing that we need to be careful about, is we need to get on the right page, right? And so that's the crucial part. There's a lot of pages in here. We got to get on the right table, so we got to pay attention to the details that are on there. Annex C is great, but it's easy to get on the wrong page. So I'll show you some very common mistakes that people make as they're going through Annex C. All right, so let's try one. How many 14 gauge RHH conductors with the cover can be installed in trade size 1 EMT? So we're just going into Annex C, and we're going to flip the page to page 774. If you look at the top, it says EMT. Is that what we're looking for? Yes, EMT. So we're on the right one. Now we're going to go to a number 14, RHH. So we find RHH, that's the first thing on the page. We go to number 14. And we go over to 1 inch, and it says how many? 11. Now, look about halfway down the page. It's got RHH with an asterisk next to that. What did we learn about that asterisk? Earlier it meant with the cover, right? Or I'm sorry, without the cover. And so here it actually means without the cover as well, but we don't have to assume that. We can always look that up, and if we just turn a couple of pages, we will find that the asterisk will indicate on there that that is without the outer covering. And that's going to be on page 780, right? Down at the bottom it says asterisk RHH, RHW, and RHW2 without the outer covering, okay? So we got to pay attention to those things. Make sure that if you see an asterisk, you know exactly what that's for. So I can do 11 14 gauge RHHs with the cover in size 1 EMT. Okay? THHNs. THHNs. This is in EMT as well. EMT, find our THHNs. And so if I'm looking for THHN, I can see that on the top of page 775. And I've got number 8s, right? And what size is it? 3/4? And so it tells me that I can do 6 of them, right? So 6 number 8 THHNs can be installed in 3/4 EMT. How about THHNs? If I've got number 12s and I got a 1-inch. THHN number 12s, 1-inch, says I can do 26 of them. And so 26 conductors can be installed in trade size 1 EMT if they have THHN insulation on them. Okay, ENT. I'm on the wrong table, right? So we want to make sure that we find the ENT table. And so it's actually the next table here, I believe. Yes, it starts on page 778. And so you can imagine if I was looking for something oddball that I could be flipping 80 pages, right? So the easiest way usually to find something is to go back to that little table of contents at the beginning on page 773. You can say, oh, ENT, page 736, okay. Wait, that didn't work. ENT, never mind. Remember how I said that was easier? The table of contents in Annex C is wrong. So, at least in my printing. Maybe in your printing it got updated on the thing, but in my printing, they forgot to update that, okay? So, don't pay attention to that. You're going to have to just find stuff, all right? So if yours is the same as mine, I think I have a first printing on there. They didn't catch that error. They need to fix that error in future printings. Wow, that's very unusual to catch an error in the code book like that. All right, so now we're just going to have to manually find ENT, right? And so we flipped to table C2, which was starting on page 778. It says XHHWs. XHHWs, I can find that at the bottom of page 779. And we're looking at number 6s, right? And we go over to what size? 1-inch. And it says I can do 5 of them, all right? That's basically how you use that table, okay? And that is how you use the tables in Chapter 9 and also in Annex C as well, all right? Voltage drop we handle on another video. We're going to use that off of Chapter 9, Table 8. Okay, we'll use that table, Table 8, but that's actually on another video. And so when you run across that, you can watch that video. It's in the video that's called Miscellaneous Calculations. It'll have voltage drop. It'll have unbalanced load voltage drops, things like that. And then there's one for our series and parallel calculations as well, all right? Again, if you have any questions on any of this stuff, that's what I'm here for. My name is Bob Delahunt, and I am in the office Monday through Friday, 9:30 to 6:30 Texas time. And you can call me at 505-883-3885. Thanks for watching. And again, don't hesitate to call if you've got questions. Thanks.